sketch the graph of x squared over 25 minus y squared over 9 is equal to 1. Now this is the equation of a hyperbola. So whenever you're drawing hyperbola, we need to find the x-intercept, y-intercept, and the asymptotes first. So let's first find the x-intercept. So x-intercept, you get the x-intercept when y is equal to 0. So the first thing is, let's find the x-intercept. Okay, so x-intercept is by setting y is equal to 0. So this is x squared over 25. This becomes 0 is equal to 1. So multiplying 25 to both sides, this implies x squared is equal to 25. Now this implies that x is equal to plus or minus 5. So x-intercept is plus or minus 5. Okay, so let's find the y-intercept. So let me change color. Your y-intercept is when x is equal to 0. Your y-intercept is when x is equal to 0. So if you put x is equal to 0, so this will become 0. So minus y squared over 9 is equal to 1, which implies minus y squared is equal to plus 9, which implies y squared is equal to negative 9. Now if y squared is negative 9, you cannot find square root of negative 9 in real numbers. Okay, so you can't say you have no real solution. You can say no real solution. Of course, you can find complex solution, but we are restricting ourselves in real numbers. So as this is a negative number, you can't find square root of a negative number in real numbers. So we say there are no real solution, which implies there are no y-intercept. This means graphically no y-intercept. Okay, so this is the x-intercept and y-intercept. Okay, so now the next is to find the asymptotes. The next is to find asymptotes. Now asymptotes is a line. It can be a straight line, it can be vertical or horizontal, it can also be an oblique line. Okay, so asymptote is the value which the function is going to approach. Okay, so in other words, asymptote is the value when x is approaching positive or negative infinity. So let's first write this in terms of y. Okay, so let's write the equation. Equation is x squared over 25 minus y squared over 9 is equal to 1. So let's make y the subject. So to find asymptote, we are asking the question, what would y approach when x approaches positive or negative infinity? So let's make y the subject. So I can say y squared over 9. I hope you can see that is x squared over 25. X squared over 25 minus 1. Okay, so what I did is I moved this to this side and this to this side. Okay, whichever way you understand. So if y squared over 9 is x squared over 25 minus 1, which implies multiplying 9 to both the sides, you can say y squared is equal to 9 over 25 x squared minus 9. Okay, so now you have to ask the question. Okay, so y is, you can say, plus or minus square root of the whole thing, 9 over 25 x squared minus 9. Okay, so now you have to ask the question, when x approaches positive or negative infinity, it doesn't matter because it is x squared here. So when x approaches positive or negative infinity, what happens to y? Well, when x is approaching positive or negative infinity, this is going to be a huge number. Okay, so the main player when x approaches positive or negative infinity is this x squared. So this becomes almost insignificant. Minus 9 doesn't have any role, or you can say it's become insignificant. It doesn't matter or doesn't make any difference when x is approaching positive or negative infinity. I hope you understand mathematically. You can plug in a huge number of x and square it, so that will be infinitely large. Okay, and then if this is infinitely large, this is not going to matter. Okay, I hope you understand the maths there, which implies y, you can say, is approximately or almost equal to its. It doesn't matter if you want to be exact, but you can say y would be approaching. You can say y, you can say instead of y is equal to, you can say y approaches which number? Square root of 9 over 25 x squared. Okay, which implies y is almost going to be equal to 3 over 5 plus or minus 3 over 5x, and that's your asymptote. I'm going to plot this later on. So this is your asymptote. So you can say the equation of asymptote is going to be y is equal to plus or minus 3 over 5 x. Okay, so this is the main thing. So the x-intercept is plus or minus 5. There is no y-intercept, and the asymptote is plus or minus 3 over 5x. So the x-intercept is plus or minus 5. That means the x-intercepts are 5, 0. So this is one x-intercept, and this is the other x-intercept. The asymptotes are no y-intercept. The asymptotes are plus or minus 3 over 5x. That means this is rise of 3 and run of 5. So this is one line. So it will always pass through the, in this case, a standard vertex. So it's standard hyperbola will pass, the asymptote will pass through the origin here. So minus 3 over 5, that means this is run of minus 3 over 5. So let's draw the asymptote first. So the asymptote is a line. So let me draw a dotted line for asymptote. So this is asymptote. Generally you draw a dotted line for asymptote. So let me draw a huge line here. There's a reason. So let me drag this. So this is one asymptote, and this is the other asymptote. Okay, now so here this is your a, this is 5 and this is minus 5. Okay, so your graph would look like this. This is the vertex, so this is x-intercept is also called the vertex here. So the graph would go, let me draw a rectangle so that you understand how to, the limits. So yeah, it's, let me draw a rectangle, explain what I mean by this. Okay, and okay, so let me slightly drag this down. This has to pass through 5 here. Okay, and okay, that's fine, and yeah, that's fine. So I'll have to draw a rectangle. I want to explain something else. Okay, so this is a rectangle. Okay, so this is your a. Okay, now when you compare your standard equation, so this is 5. So let me go. This is 5. This is 5, and this is 3. This is 3. This is 3, yeah. Okay, that means this would be square root of 25 plus 9. Okay, so this length using Pythagoras, this is square root of 25 plus 9, which is square root of 34. This is square root of 34, so this will also be square root of 34. And the square root of 34 is the focal length. Okay, this is square root of 34. And then you can draw a circle. So let me use a compass. Okay, I'll have to drag this down. Let me cut and paste it here. Okay, so let me paste it here. Paste. So this is my compass, electronic compass. So let me draw a circle. So I want to draw a circle. Okay, that's fine, and I'll draw a circle now. This is a circle. Okay, perfect. I want to delete it now. So this is a circle, and this is, if this is root 34, this is 25 plus 9 is root 34. So this, from the length from year to year, is also root 34. So this length is also root 34. This is root 34, and that's your focal length. Okay, so this is also negative root 34. This is minus root 34. So, and then you have to draw the hyperbola. The hyperbola would be passing through this vertex, so it will be approaching this line, which is asymptote. So it will pass through the vertex and be approaching that asymptote. And this is the other branch that will be approaching this line, and that's why it's called an asymptote here. So this is one branch, and same way you do the other branch. From here, the function is approaching this asymptote. Okay, so here you can say your focal length. So focal length is always this squared plus this squared, which is square root of 25 plus 9, which is square root of 34. So let's confirm this square root of 34 on a calculator. So let me square root of 34, shift square root of 34 equals 5.8 in 1 dp. So your focal length, your f, let me call that f, is plus or minus 5.8. Okay, so let's check this on a calculator. If you have a graphic calculator, and if you go to conics, so let me drag this up so that I can see the equation. Okay, so go to conics, and go to hyperbola. This is circle, so this is hyperbola. So here your h, your a is 5, your b is 3, h and k are 0, and then you draw it. Oh, so this was, sorry, so this is ellipse. I want to go to hyperbola, so sorry. So this is, then draw it. So this is here. So let's check. So the focus is 5.8, and if you press this, minus 5.8. That's the first thing. And X-intercept is 5 and negative 5. Y-intercept not found. Okay, and G-sol, your vertex. Your vertex are, these are, X-intercept and vertex are one and the same. Okay, and your asymptote. So these are the asymptotes. Do you have anything more? Of course, you have your eccentricity, which is your center is of course 0, 0. I didn't talk about center. The center is 0, 0. And finally, eccentricity is C over A. So let me show you that. G-sol E is 1.17. Okay, so let me explain that. Eccentricity E is eccentricity, which is C over A, which is square root of 34 over your A. A is the denominator of A is phi here. Okay, so this is your A, and this is your A is phi, and your B is 3. And your C, which is your focal length, is square root of 34. So square root of 35, square root of 34 divided by 5. So let's use the calculator. This is 1.17. So shift square root of 34 divided by 5, which is 1.16, or this is your eccentricity.